Welcome to ClickMyProject.com.
Our project title is VLSI implementation of decoding algorithm using e.g. LDPC codes. Our project abstract is the low density of fatigue check code. This is the LDPC of code. So first we are designed that the vanilla code. So the vanilla code based on the BIST of code. So this is a built-in shift test, the schemes of the solution of testing in VLSI device. So the VLSI device was during the test of circuits based on the concepts of the test latency. So this is a CTL concept. Okay. So this is a building in self test, the considering the pseudo random number generation. So the pseudo random generation is the LDPC of encoder and then decoder of process. Okay, so after this is a cyclic redundancy check for that RC techniques. So this is a BIST is using the make faster, less expensive of integrated circuit manufacturing test. So the BIST testing methodologies mainly focus on sign generation calculation between the present outcomes and then expected outcomes results. Our project flow diagram. First of all, this is a LDPC based on the low density party check code. So this is the main application of encoding and decoding process. This is the application based on that weapon and then medical devices and then automatics. So this is a security process. So the your IC integrated chip, the encoding and then decoding process we are using with the RAM memory architecture basis. So the first we have the testing control function. So the testing control function using the test pattern generation. So the first input pattern generation, the input pattern generation is the encoder method. So this is the input pattern generation. Normal input pattern generation 00001. So this is the 2 power 8. So we are using the 8-bit multiplier architecture. After that, using the cut with the DFT sections. After that, the test outputs result functions. So this is a 8-bit multiplier, we get the 16-bit multiplier result. So after the testing result function, using the function process. So this is the using of the signature output response compressor. So the compressor we are using the 4x4 compressor. Finally calculate the fault detecting process. So this is a low encoding the result, we have the decoding of process. So this is a fault detecting process. Finally fault status level and then performance analysis will be also calculated. The performance analysis be calculated in the throughput, LUT and then memory storage process and then performance evaluation of this process. Our simulation process, we are implement the Xilinx ISC 15.7 tool. So the tool we are using the virtual part and then Verilog board. So we are checking that the two implementation. One is the implementation and then is the simulation model. The simulation model based the behavioral check and then simulation behavioral model. So the implementation was we have designed the RTL diagram and then result basis. So we are using the simulation model to check that behavioral check syntax and another one is a simulate behavioral model. So this is a behavioral check model completely successful. So after that simulate behavioral model. So this is a take time to waiting for the 23 sub compilations to finish. The CPU based on the 841 minutes. So this is a reset. This is the on and off condition. So the one will be on. So the clock set 0. So this is a reset. This is the output. So this is a 8-bit multiplier we have proposed as a 16-bit multiplier. So we can finally calculate the 32-bit. So this is the types of encoding and decoding of process. This is the encoded data. After finally this is the encoding process. After the decoding of the process. So this is a reset clock. This is the input data. This is a key. This is a decoding. This is the encoding of process. This is the decoder. After the original data will be retrieved. So this is the RMDL. So we check that behavior model and then simulation model. So set the reset value 1, another one based on that the clocks set 0. So this is our input data. This is a coding of P1 P2, the key based on the private key and public key based.